Okay, we're gonna start, jump back into Unit 6 here. We're gonna do one of the coding activities today. Again, remember next week we have a short week because of Thanksgiving break, so we're gonna have to kind of condense some things here. So right now I'm gonna skip Unit 6.4 here and go on to 6.5. May return to 6.4 later on, depending on how we do it for time. But I want to try do 6.5 today. And it's a nice programming activity, and it introduces some of introduces how we encrypt and decrypt messages with a real simple algorithm here. So we're going to go there. So I'm going to go to 6.5 here in mobile CSP. I'm just going to walk through the slideshow real quickly, and then just make sure we're getting some of these terms, and then we'll jump into the coding part of it. So we're going to look. I mean, part of this deals with cryptography. It's a word you probably heard before. So just writing things encoded or in a secret message or somehow so that people who don't know how you're encoding it can't read the messages here. And it's two parts. We encrypt messages and then that makes them secret so you can't read them, and then we'll decrypt them. So those are the two words we'll try to use: encrypt and decrypt for them. You also sometimes hear them going from plain text to ciphertext. So plain text will be the normal message, and then a ciphertext will be, again, when we've encoded it. So it's impossible or difficult to read without decoding it. So now, in general, we'll start with what are called symmetric encryption there. We'll have a key and an algorithm, and symmetric means we use the same key on both sides here. Both parties will encrypt it the same way. Eventually, yes, that'll be our starting point from it. So again, here we're sending from and this is just the typical wording or naming for encryption algorithms. We're sending things from A to B. Here, point A to point B, and so we often label those Alice and Bob. So Alice is sending a message to Bob, A to B there. And so Alice is going to encrypt the message with some key, send it over, and Bob is going to then have to decrypt it and use that same key to decrypt the message. And in between, our evil Eve is going to try to decrypt or snoop and see what the message is there. And so we'll see this kind of process, and we'll look at different kinds of doing keys and that sort of stuff. So the first thing we're going to do is the substitution cipher. This is probably the one you learned in third grade or whatever when you started. I don't know, did you try to do this? This is just when we're going to shift letters over or move things around. So like here, Alice is going to say, oh, my key is 3. I'm going to shift all the letters 3 over in the alphabet here. And Bob has to know that same number because he's got to shift them back 3 letters. So everyone may agree, okay, secret number today is 3, so they can do that. And so we'll shift the letters 3 over. What we generally do here is we make one way of thinking of it is you have 2 different alphabets here. You have the normal alphabet, and the cipher alphabet is just shifted. So we take the first 3 letters of the alphabet, A, B, C, if our code is 3, and we move those to the end of the alphabet there. And so A becomes D, B becomes E, so we can do this direct mapping there. You can also think you're counting ahead 3, but as far as the computer goes, it's kind of a nice way to do it if we have 2 copies of the alphabet, one on top that's normal, and then the shifted one. So we just have the plain alphabet and the shifted alphabet down below here. So again, this shows, so hello, H will match to K, E will match to H, And L and L both match to O, so we end up with KHOOR as our cipher, our encrypted text for that. And you can try this out in this algorithm for this. Now, as far as breaking this, it's not hard to do here. If Eve really wants to crack the message, there's only 26 ways you can shift it. Well, there's only 25, 26 swings it all the way back. It's not a very good shift there. So there's only 25 ways to shift it. You know, if it was an important message, that if someone were to pay you, I always think with ciphers, if someone were to pay you $100,000 to decode this thing, would you do it for $100,000 there? And geez, I would try out 25. I'd do that for $100. 100,000 would be, no problem at all. I'd do it there. And so that's often when we're looking at the internet. If someone would do it for 100,000, someone's going to then do it there. So Eve is going to try all the combinations there and figure out which ones. And then we're going to look. So we'll look at a more complicated version of that first, but we're going to implement this shift cipher first here. So I'm going to scroll down to part 2 here. So in part 2, we're going to open this up in App Inventor and implement this Caesar cipher sort of stuff. So I'm going to click on that. I got to give it a new name. Small 25. Okay, so we want to get to this point where we have our message here, our app. We have a spot to enter the plain text, and it's called the text box plain text. We have a spot where we're going to display the ciphered text. And it should be get down to part 2 here, and then click on that link. Right there. Part 2. And you might also want to open up the way up at the top, right before part 1 is the text version of the tutorial. So that will help us with some of the coding stuff. It walks through some of this, but then we'll get into the coding there too. So yeah, so we've got the text box plain text, text box ciphertext, and then the shift, we'll be able to enter a number here, and then we'll be able to enter encrypt or decrypt. So if we hit enter encrypt, it'll take the plain text and generate the ciphertext. If we hit decrypt, it'll take whatever's in the ciphertext and convert it back to the plain text here. So that's our, and we have this label here if we want to just display something as we're working on things. Okay, let's look at our code. And there's a fair amount of code that's here to start with. And again, this kind of the text handout walks you through this stuff. There are 2 variables, global variables that we'll be using, the plain alphabet and the cipher alphabet here. And so the plain alphabet is just the A through Z alphabet. Zoom in a little bit more on this. The plain alphabet is going to be our lower alphabet, and the cipher alphabet, we're going to redo this. So if we're shifted over a couple, we'll do it. Let me grab some samples here. Our cipher alphabet, and we're just going to capitalize one just so we can kind of keep track of which one's cipher and which one's not. We don't really have to, but it's just nice. So here would be the cipher alphabet. And again, we're going to cut this apart. So we're going to want to take, like, let's say the shift is 5. We're going to take the first 5 characters and move it to the end there. Okay, and that'll be our alphabet will be when we do that. So again, if the shift is 3, we're going to take the first 3 characters and move it at the end. So what we're going to do is we've got this init cipher alphabet method there, where we're going to take this alphabet, we're going to split it here by, so we're going to do 2 segments of text. We're going to grab our normal text and we're going to go from whatever the shift is +1 to get this part of the alphabet. And then we're going to get this part of the alphabet and we're going to move and stick these 2 together. So that we're going to join these 2 together. So all this does is basically do what I just said. So if we say shift of 3, it will go to the 4th element and grab that text all the way to the end. And then it'll grab, that'll put it at the beginning of this string. And then it'll grab the first, starting at 1 to the shift. So that'll be this first 3. It'll take that off. And then it'll join this one with this other one and get that there. So this is just a code that will set up our cipher alphabets for us. So we don't have to do that, and we can do it for whatever shift we want. That'll be all done for us here. But we have to remember we have to call init cipher alphabet. It's just a procedure. We're not calling it anywhere. So the other thing that's here is our button encrypt. Remember, there are 2 buttons. There's encrypt and decrypt. We're not going to do decrypt yet. So we're just doing the encrypt first. So there's the encrypt button. And we're just calling a method here. And we're going to set the ciphertext there. And we're going to call this method called Caesar encrypt. Pass it the plain text and the shift. So again, the plain text is this part. So we're going to take that and the shift. So whatever message we type in there and the shift, 3, 5, whatever we're shifting it to in this example, we're going to pass that into this special method called Caesar encrypt. And that's what you're going to create now, is this Caesar encrypt. And then whatever it returns, it'll be. Now, one thing that's new here is usually our methods were like this, or our procedures were like this. If you remember when you look at a procedure, there is 2 kinds of procedures here. One is this do, and one is a result. We call this a procedure, and we often call this a function that returns a result. So we often use the term function here. It returns it. So if we make something like this, it is called by itself. But if we make one, it's called by itself kind of like this. If we call one like this with the result, its puzzle piece is different. See how it has to be called and saved somewhere, attached to something there. So when we do, and so this one is a result. It has to be attached to something. We have to return some value here for this. So we have to make sure we're sending some value back. And that is why when we call it, it looks like this. And we're displaying it in the ciphertext for this. So, okay. What do we want to do? So again, going back here to our lesson. So this walks through our variables, the events, the function here. And again, we want, let's talk about local variables. So we're going to use 3 local variables. So there are global variables, and there are what are called, we can set up local variables. Local variables are only good in this block. They're good because sometimes we run into problems. We have global variables and some other code, another block is changing them. So something's going wrong in our program. We don't know why there, because some other block might be changing our global variables without us, because if you have lots of blocks around. So one thing nice is if you have local variables you just need in this one block, well, we can add a little block here for local variables. So that's what there are. We have one char, CHR, index, and ciphertext for this here. So let's try some things here. Question is, how do we have to break this up? What do we want to do? And that's one of the things you got to kind of get your head wrapped around when you're doing programming is how to take a problem, break it down into bite-sized parts, and see if you can do the parts. So like, how would we do this? So we want to take the plain text and convert it into the ciphertext here. How we want, so that's what we want to do. How do we, but that's too big. I don't know how to do that. So can I break that down into parts here? So, okay, the ciphertext is going to have a bunch of letters in it. Maybe I can just think of how do I do each letter? So I'm going to go through each letter. How would can I figure out how to do one letter? If I just had a single letter here, how do I convert that into a ciphertext there? So if I have a single letter, I'm going to shift it over, in this case, whatever the two amount. And let's just say I always think about shift over two. How do I shift it over to? And so what we're going to do is use our alphabet here. Again, we have our two alphabets. We have our plain text and our ciphertext alphabet. If we have a letter in one alphabet, like the eighth letter here, we can grab that eighth letter out of the other alphabet. So that's one thing we'll be doing is we'll be like, if we want to convert, we want to do hello, here we're going to find H in our normal alphabet. It'll be 8. And then we're going to find that corresponding letter K in the cipher alphabet. So the eighth one. So I know if I can look through my text, if I have a letter, I'm going to look through my alphabet, find what letter that is, that eighth letter, and I'm going to shift it down and do it in my ciphertext. I'm going to find the eighth letter in my ciphertext too. So you might be thinking, why don't we just find the letter and then find the index and then add like 2 to the index, and that works out okay. But you do have to watch things where you're wrapping around the alphabet also. So if you're finding and shifting so many letters, you do have to do it. So that's again, with these algorithms, there's multiple ways of doing them here. So this textbook teaches this 2 alphabet approach, which is, okay for it. So it might not be the way you would think of doing it, but that's how we're going to try to do it here. So again, trying to break this down, I'm going to go letter by letter. I grab a letter, find it in my alphabet, I don't know what index it is, and then find that corresponding one in my other index there. So again, what is my first thing? I'm going to just, can I find, if I know, let's just say, can I just find the first letter in my plain text and just print that out and return that? So why don't you see if you can look at your block here, and we want to just return. So we need a special thing that returns something, but we want to return. So if you look in the text, is there a text thing that you can grab that looks like this, where it'll allow you just to grab the first letter of the plain text? So you have the plain text here. Can you just return the first letter? And again, we'll try this out in different ways there. So see if we can find the first letter of the plain text and return it. I'm going to plug in my phone so I can display some of this stuff too. So again, when you look through your blocks, if you hover over them, it'll tell you what it does, like split. If I just stop there, it should tell me what it does. Like split the text into pieces separated by spaces, or segment. Extract a segment of a given length at a given of the given text at a starting position. So I'm going to try that there. So what do I want to do? I'm going to grab the plain text and I'm going to grab starting at character 1, and I'm just going to grab one character. So what is that? Is that going to get me the character I want? Will that give me just the first character? What we want to do is be able to display the first character here. So let's see if that'll work. Do my connect here. I'm going to type in hello. We'll always type in plain text. It's all lowercase. This is while we're testing for now. Hello. And I'm going to hit encrypt because that's my button. And it should display H there. So this will get me the first character of the letter. Now, I didn't encrypt it there, but at least I just got that one character. So now this is going to get complicated. So I'm going to store that. So I have this char, CHR, we often, and sometimes I put an A in there, but often we just abbreviate CHR for character. I'm going to get this set character 1 and store that in here. But then I have to return a value. Now this won't click in there very well. So I'm going to look and I'm going to make sure I'm doing the right one that they show us. Yeah, they use a do, one of these do values one. So I need to convert this kind of look to that look. So under control, I'm going to find a do. So under control, there's this do one. So I'm going to do this and then my result. So I'm going to save my character in the char variable, and then I'm going to return that char variable. So this should do the same thing. I'm going to find the first character, save it into char, and then I'm going to, as a result, so I've added this do block in here and saved this in my local variable. So now if I test this again here, it should get H again for this. So. And again, we're trying to break this down into steps. So I'm doing the first character. I'm trying to convert the first character. And how did I say I'm going to convert characters? I'm going to find it in the alphabet here. So we want to find it H in the alphabet. It should be character 8. So I'm going to try to find that index. So I want to set index equal to that 8th character. So see if you can change this next so that you set index. I'm going to set index to the 8th character, or wherever this char is in the alphabet. So you have your alphabet text. I have my plain text alphabet here. I want to set index to finding char in the plain text alphabet. How do I find where char is in this plain text alphabet? So look through your blocks. What kind of block do you think? Would it be a list block? Is it a text block? Where should you look? What are we working with here? is it a math or a logic block? So we need a block to find this character in this alphabet. So see how that goes. I'm going to let you play with that a little bit. I'll wander around and see how everyone's doing. So again, I'm going to find this index in this list. So again, I'm working with strings here. Plain text is a string. This character is a string. I'm going to look under text, replace, segment. I want to kind of a search contains. That tells me whether a piece contains text. But I want to find not just true or false. I want to find where it is here for this. So we keep looking. Well, let's see. Contains text, test whether set splits, segments. So well, let's look at this contains here for this. See what there, if that's, yeah. Okay, they use start set. So let's look at that one. Start set. Oh yeah, that returns the index. That's what we want. Start set returns the index of it. So I'm going to do this start set. My text is my alphabet and my piece is the character. So I'm going to look at the char and look at that. I'm going to then, I'm saving that in the index. I'm then going to return that index. And hopefully that'll tell me, I've got to go up here. I often want to go down here to get it, but you have to go up here to do the get index. I'm going to return that index. So again, if it's rather than H now, it should be saying A, B, C, D, E, F, G, H. Should be the eighth one here. So if I run this again, I think I lost my connection. My phone goes to sleep. It seems like too fast here. So let's do this again. So I'm going to delete the plain text and type hello, hit encrypt, and now it's saying 8. So the index is 8. We found the 8th spot there. So the index is 8. Now my ciphertext is going to be the corresponding one in the other alphabet here. So again, we've got these two alphabets. I found H. It's at the 8th location. Now I want to get the 8th letter out of this other alphabet. So how do I do that? I'm going to set ciphertext equal to that. So again, I'm going to look through my text and I'm going to use so start text returns an index, contains split at segment. I think I can use segment again here. So I'm going to grab my ciphertext this time. Get the global ciphertext. I'm going to start at index, get my index, and I'm just going to get one character here. So I'm going to grab one character. So now my ciphertext, I'm just going to grab one character out of this. And now, again, rather than returning the index, I'm going to want to print out the ciphertext here and return that. So hopefully that will work. here, let me see. So now if, so, oh yeah, when I ran this, it gave me an error. Let me see. I stopped the warnings, but it gave me an error that the my ciphertext wasn't long enough. And I go, well, I'm going to the index, the eighth character. The ciphertext should have 8 characters because but I look in here, I don't initialize it to 8 characters. I set it to blank because remember, there's this init ciphertext that's supposed to set that up. So I should be calling init ciphertext somewhere here. I could call it in my button, or I could call it here. I think I'm going to call it in my button here. So I'm going to go up to our procedures. I'm going to find my init ciphertext. I'm going to make sure I just call that here. And I'm going to get the shift. Well, I could do it here. Yeah, let's see. I think they do it in the other part. So maybe I should follow their example. Yeah, they call it here. Okay. I'm not going to call it there. I'm going to call it in here. So before I start any of these things, I'm going to init the ciphertext in my do loop here. And then I have my shift up here. I can get my shift and stick it in there. So now if I have that, I should be able to look at this and say it should return the right alphabet. Now I thought it should return an 8 here or a K, and it's returned a J. That didn't seem right. But then my shift is only 2. If I change my shift to 3, then it'll return a K. And it shows our 2 alphabets, which are kind of nice here for this. Okay, so I've broken this down. I find the character, the first character starting at 1. I find its index in the plain text library or alphabet. It's in the 8th letter. And then I find the corresponding letter in the ciphertext going to the 8th. What's the 8th letter in the ciphertext? I set that to ciphertext. And then I return that. So it's looking good. So now I can do 1 character. I want to do it for all the characters. I want to repeat this again and again. So I could duplicate. I have this set of blocks. I could just duplicate this whole set of blocks again and again for however many characters I have. But I don't know how many characters I have, to tell you the truth. That's one of the problems. So I can't just, duplicate it. So I'm going to use a loop in here. So let's look under control for my loops. I have a for each item in a list, for a number of things, for each key in a dictionary, while some tests there. So I know how many characters are in my word when I hit the button. When this starts, I'll know that. So I can use a for each loop for each number in this stuff. So I'm going to stick that in here, and I'm going to put all this code in this. So now I'm going to say for each number from 1 to, I'm going to do the size of my text here. So that's my plain text. How do I get the size of that? So under text, I can get the length. Yes, length. I can go from 1 to the length of the plain text here. And my number will count that. Often we call this something else like index here, but I already have something called an index. So this is my character number. So maybe I'm just going to leave it as number for now. I'm trying to remember what they called it K. I don't like K. I'm just going to call it number. Okay, so I'm going to loop through. This number is going to count each thing. So now I've got to change this code. So right now it's always grabbing the first character. I want to change it so that it always does this character here. So I'm going to now which one is this? So set text, the plain text starting at 1 of length 1. I always want the length to be 1, but I don't always want to start at character 1. I'm going to get rid of that and get this number here. So loop through, every time I get a number, I'm going to grab that character, find that character in the alphabet, and present it out here. That's looking good. It's not quite right yet, but it's close. So let's see if that works. I'm going to go back over here. Hello, encrypt. It's just saying R. Why is it just saying one character? And why R? I thought if it's, is it just doing the first character? That should be K. Why R? And I might notice that O, R. So O, it's doing the last, it's showing me the last character here for this. So I want to look through this. Why am I only getting the last character in this code here? So I'm initializing my local variables. I'm initializing my alphabet. I'm looping through each character, grabbing the first, whatever character that I'll do, the first character, second character, grabbing each character by number, storing it here, finding its index in the library, and then converting it and saving it to ciphertext. And then at the end, I return that ciphertext. That's good. No, we want to do the ciphertext there, but we don't, right now, we keep overwriting one character onto the ciphertext. So I find the first one and save that to ciphertext. I go find the second one and save that to ciphertext. Find the third one and save it to ciphertext. I keep overwriting this ciphertext with one character. So what I want when I find a new character, I want to join it to the ciphertext here, there, the concatenated on. So how do I join or concatenate? Is there a concatenate block? No, there's a join block though. I'm going to join the ciphertext. So I'm going to take whatever the current ciphertext is and add this new block to it, the new one to it. So now if I do this, it should take my hello and translate that correctly for this. So this is the text. Let's see how, I was wondering how, I try to follow their example somewhat. Let's see how the close this is. So this is their example of this. So again, we both are doing CIS. We're both initializing our variables. We have a do loop. We're calling an it cipher. Again, I wanted to do this up here. I would have done it here, but again, shift isn't there, so I would have to have gotten this. I would have done that there. But we'll stick with the way they did it. Okay, that's not a bad way. We call it a cipher. We have our for loop here, starting at 1 and going to the length of the plain text. We're grabbing each character, grabbing each index there. What is this if they have here? They have some if here. What is that doing here? So they have some if here, there. So they must be doing some error checking there. So what breaks this? Is there something that will break this? So if I go back to this and I type in hello, what if I type in a shorter word? Encrypt. That worked. What if I type in a word with an uppercase letter? Now I get an error for this because it's trying to find the uppercase letter in it. What if I try, okay, so I know uppercase doesn't work. What if I try and do a, and a space in my thing. I get the same error for this. So like a space. So again, when I find my index, what if it isn't in my alphabet? What if it isn't A, B, C, D? What if it's an uppercase letter or a space or something like that? What do? I get this index. So what is index if it doesn't find it? So I can look at this. I'm going to go to my block and see if it tells me. I'm saying start text at. Okay, oops. Returns the starting index of a piece of the piece in the text, where index 1 denotes the beginning of the text, returns 0 if the piece is not found in the text. So again, if it's not found, it's going to return 0. So if I find index and it's 0, I shouldn't go do this. I should just say do something else there. So that's what they did here is they had this if text is 0. So I'm going to add that. So I need a control. I need an if then else here to stick in there. I'm going to check if the index, I'm going to go to my math and grab my equals, and I'm going to check if the index is, and what did it say it was? It would be 0 if it didn't find it. And there. So if it's 0, then I'll want to do something else. And otherwise, if it finds it, it'll be not 0. And I can look it up in my alphabet here. So that's what I want. So what do I want to do here if it doesn't find it there? So I'm going to join something to the ciphertext. What should I stick in there? What do they do? They just put the character unencoded there. I'm gonna I don't like that. I'm just gonna put in a dot maybe, or maybe a dash. Let's do a dash there as unknown character. So now, if I decode something like this, it'll say where there's a space, it'll put in a dash there. And if I do something with an uppercase letter, it'll put a dash for the uppercase letter too for now. Okay. So the next thing we want to do for enhancements is the decrypt. Right now you do it. And so I'm going to leave that up to you. Can you so here's my Caesar encrypt. Just copy that, duplicate that, call it like Caesar decrypt. And again, when we hit our button, we want to add something with our decrypt button. So find your decrypt button. And when we click on that, just like we did over here, I'm going to duplicate that. When we hit the decrypt button, I want to, but not call Caesar encrypt. I'm going to call Caesar decrypt with the same stuff. The shift, I'm in the right spots, and the text. Okay, so add the decrypt button click, and then duplicate your encrypt to decrypt, and then see if you can go through here and what do you have to change. So when we did the encrypt, oops, where is my here? When we did the encrypt, let's find my alphabets here. we went through the plain text alphabet. We found our letter like H in the plain text alphabet, found its index, and then grabbed the corresponding stuff from the ciphertext. So you want to do the opposite when you decrypt. You want to find it in your ciphertext, find the corresponding index, and then pull that out of your plain text. So see if you can change this code so that decrypt will work. Can you figure out what parts of it have to change so that you're going, rather than from plain text to ciphertext, you're going from ciphertext to plain text, right? See if you can get that. All right. So if you do get that to work, a couple things we want to do is extend the alphabet. One thing I would suggest is with the uppercase, lowercase, is to convert all of your thing to lowercase if you can, because our alphabet is all lowercase. So we could extend this. We could make a bigger alphabet. So one way of handling this is to duplicate the alphabet and put a longer alphabet in here. So like if I have this alphabet, I could add that on here. And that would handle uppercase. The other thing you can do is you can do it so that whenever you look at your text, you just convert it to lowercase there. So that would be another way of handling it. So see if you can extend the alphabet. Now, maybe you want to add some special characters to this there. So besides this, what other characters do you want to add for this? And then maybe, maybe like a comma, a period, a semicolon, a dot, or whatever, some of these other characters. Maybe you want to put the numbers. I don't know. You can decide. And it will encode all those. And that's one of the nice things about having this alphabet way of encrypting things, is that you can add whatever characters you want. Yeah, so one of the things, yeah, it will convert a space to, well, if you put a space in your text, it'll convert it to a letter there and back, which might be. The other thing, it would be, they suggest handling space separate. Preserving blank spaces between makes it easier there. So to make it more different, write it so we don't do the spaces there. So you have to figure out how to handle spaces. Do you want to keep them there? Do you want to convert them to a letter instead? Or like it suggests, do you want to just print out every 4 or 5 characters and in a space? So okay, I'll let you finish up with this. See if we can't handle everything for our reflections here. Post a screenshot of your decrypt function. So get that working. Describe what the decrypt function is here. So write a paragraph to kind of describing the general process. Function and procedures, that was when we were talking about this here, where when we call something, does it look like this kind of puzzle piece or this kind of puzzle piece? So a function is a puzzle piece, but we have to call it where we and put it as a result, have a result, and we return it somewhere. I'll just give you a hint. Look through this code, and everywhere, basically here, we took plain text and converted it to ciphertext. There, and when you decrypt, you want to take ciphertext and convert it to plain text. So the first part would be everywhere there's plain text, change it to ciphertext, and everywhere there's ciphertext, convert it to plain text. Yeah, well, yeah. But the next question is, okay, we did that. Do you want to change this here, the plain alphabet? So. Okay, so let's try. So, try that again. See, so, if you want to change this plain text, you can to ciphertext and back and forth, but that doesn't necessarily pull from. That's not the same as this text here, which is what we're doing. And so let's back up to our button click. So when we do our button click here, we're going to call this, and we're going to pass in this is passing in the plain text. So this is where we want to switch it, not down here. So we want to pass in our ciphertext up there. And then you should just rename this one. Rather than changing here, just rename this. This will be the cipher. You'll be given the ciphertext up here for this. And then this variable here, you're creating the plain text. So you want to just rename that probably to be plain text. Yep.
But I can't find out where bug is.
Let me come over here. So again, I'll come over in just a sec. I'm passing it. I'm renaming this ciphertext, renaming this plain text, and then and then again, you point out the alphabets. That's where you also want to change. You want to change the plain text alphabet and the ciphertext alphabet and see how it works. So I'll leave this up on the screen and see if that makes sense.
Oh, sorry to keep you waiting. This is my thing. You'll notice I haven't plugged this in because what you're going on with this.
Right.
You put this.
Either one would be okay.
What? So before I had the lowercase h now, that no matter what I put in, it's just CC. Why would it do that? No, I mean, I really looked this over.
Right.
It's like I couldn't figure it out. So I mean, maybe a percentage would help.
Right. So I think
well, and I go up here exactly like you did too.
right. Okay. Yeah.
To
So
the best of my knowledge.
yes. So we go back down to that other one. So we're doing this loop here for each, and we have this number. We use that number. We're getting that number here. So that's good.
I need to put that back in.
No, yeah.
If it's
So
okay.
we're getting that number, and then
That's a function.
No, I think that was okay. So we're getting that number.
But I did not plug that back in, and we're right here, so I have to plug in the function. Sorry.
So and now here, getting your text here, finding the index out of that text, that's right. There, and you're getting.
Yeah, I tried again. I just refreshed it
right.
too. Well, I suppose it would, let's see. Can I refresh it? It'll be plain text. Plain text. And then just more seats.
More seats.
Yeah.
Right. There, so,
That's so weird. I was onto this, oh, I really would have this here, I think that was, working, but I don't know. Yeah, and- I don't know.
oh, you can run in this and then.
Probably, that was my best guess.
Right, yeah.
Yeah, I don't know. Does it look like what you did, like, it doesn't look like it's in the right place? Before, I think I was getting the H, because I had typed out, and it's
Yeah.
putting capital letters, and
Right.
I put the H
Oh,
on the end.
yeah,
Is yours working? Yeah. I would both encrypt and decrypt.
yeah.
Yeah, I might. I think that's why I was having H four, like, I had manually done that, but
Oh,
we're trying to program that, so
Yeah,
I erased it and now I get C.
right, yeah,
This all we're doing,
yes.
so I'll go.
I'm just going. Take the better. No.
I mean, I guess I could look at the book. And see. what piece
Oh,
is
I
missing.
know, so here, the piece
Yes, this.
that, you wanna get rid of that.
Oh, okay, I thought you put the dash there.
No, not there, it, oh wait, yeah, I guess so, I'm trying to remember, like, this, let's see, oh, okay, yeah, you wanna pull that out and put that up here,
And I need another piece.
then you
there.
wanna, yeah, you wanna duplicate this one. And put that up there, and then just get rid of that, this whole segment part,
This part, and then I.
and that's where the
double-
dash will go right there.
Oh, my word, thank you.
Yeah. No, I wasn't saying that, by the way.
No, well, I got very confused, I'm sorry.
That's okay.